Hello again. This is the second video to go along with section 17 on solving quadratics. This one is focused on the square root property. So let's talk about what the square root property says. If g squared equals a, so if something squared equals a constant, then in order for me to figure out going backwards what that g had to be, I'm going to have to be able to take the square root of both sides because squaring and square root are opposites. And let's think about why that is. If I know that 2 squared equals 4, I also know that the square root of 4 is 2. Okay, so that's the definition of the square root, is that you're defining what squared equals that number. So what would happen here is to get rid of the square, I would have to take the square root of both sides. But when I do that, I have to remember that there are two possible roots that can occur. There can be a positive square root and there can be a negative square root. Why are there two possibilities? Well, here they are broken down into two examples. We just said that 2 squared will give me 4. That's absolutely right, because 2 times 2 is 4. But it's also true that negative 2 squared, which means negative 2 times negative 2, will also give me 4, because a negative times a negative is a positive. So I actually do have two possibilities that will make that happen. And this makes us address those two possibilities. So I have to make sure to always include that plus minus option because I don't know which root I want. I don't know if I'm saying that it's going to be the positive or the negative. So I have to make sure that I account for both. So let's see if we can put this to practice. I have x squared equals 9. So something squared equals 9. Well, I know that in order to go back and figure out what that something is, I would have to take the square root. So if I take the square root of both sides, I have to, and the reason I'm doing that is to get rid of the 2. I have to account for the fact that there are two possible ways to get 9. There's going to be a positive root because 3 times 3 will give me 9, but also negative 3 times negative 3 will give me 9. So as soon as you perform the square root operation, you have to make sure you include the plus minus. So this gets to kind of the heart of the square root property. But there's something very important that you have to keep in mind if you're going to use this technique. The square root property only works when you have something squared equals a number. And it has to look just like this. Some quantity, some expression squared equals a number. If you can't get it to look like that, then the square root property is not the technique that you're going to use. Okay? You would have to use one of the other techniques, either factoring or our next video, the quadratic formula. So the square root property is very limited, and it only works for these special situations. It's got to be able to get broken down to look like this. So let's try out the square root property. This almost looks like something squared equals a number, but I've got this 3 that's in my way. So the first thing I'm going to do is a little algebra step, divide both sides by 3. So I get x squared equals 5/3. Then, in order for me to get rid of the square, I'm going to take the square root of both sides. But as soon as I do that, I have to account for the plus minus option. Okay, I have to account for the positive and negative option. I can leave my answer like this. Okay, we are allowed to do that. This would be considered an exact form. And that's when you don't simplify the square roots or the radicals. Radical is also another word for the root sign. But I can also get an approximate answer if I plug this into my calculator. Now, here's the word of caution. You have to plug this into your calculator correctly. Depending on your model calculator, it might open up a parentheses for you, or it might write the whole expression underneath the radical as you're typing. You need to know what your calculator is thinking, okay? You need to be able to notice what your calculator is taking as you're typing in. So if I had to write this into my calculator, I would be putting the square root first, and then I would be putting the whole entire 5 divided by 3 in parentheses, because it's making my calculator realize that I want to take this whole thing underneath the square root sign. If you're not sure how to get the square root sign on your calculator, the x squared button is over here to the left. It is the second feature, if you see the blue square root sign there. So you would hit second and the x squared button. And you can see that that opens up a square root sign. Now, in this example, I wanted to the square root of 5 over 3. So I would put in 5 divided by 3. And you can see that my model calculator puts everything underneath the radical until I use the arrow to move out from underneath the radical. So this is how my calculator works. Your calculator might open up a parentheses, and anything that you want underneath the square root, you would have to include in those parentheses. So you have to be mindful here of what your calculator is expecting you to type in. So I do want the entire fraction underneath the square root, so I would hit enter. And I get an approximate answer if I round to 3 decimal places of 1.291. So I would say that one of my possible answers is that x is approximately 1.291. And I use the squiggly equals because I'm rounding this off. But remember, there are 2 possibilities. So it's also the negative of this, so negative 1.291. So these would be my 2 possible answers. Now, the nice thing about this is that I can check these answers by plugging it back in for x. Because these are rounded, I might not get exactly 5 when I go to see if this balances out, but you'll get very close to 5. So it should be enough proof that you do have the right answers. All right, let's try another one. Now we want to solve x plus 1 quantities squared equals 16. Well, ask yourself, does this look like something squared equals a number? It does, okay? It's this whole quantity squared equals a number. Doesn't matter if this is an expression, okay? Because I still have something in parentheses squared equals a number. I need to get rid of this square. The way I do that is with the square root. So that leaves x plus 1 on the left. But as soon as I take the square root, I have to include the plus minus option. So this is the positive or negative square root of 16. 16 actually has a nice perfect square, right? So 16, square root of 16 is 4. So this is going to be a positive or negative 4. But now this results in 2 different equations that I have to solve. Either x plus 1 equals positive 4, or x plus 1 equals negative 4. And I'm going to have to solve both of those mini equations. So when I add 1 to both sides, or subtract 1 from both sides, I get x equals 3 or x equals -5. Both of these are the solutions to the original equation. If I wanted to check to make sure that they both balance out the equation, I would just take 3, plug it in for x, and work it out. I would take -5, plug it in for x, work it out. And you should see that you would get 16 in both of those cases. So with all the other algebra that we saw, these are nice because they are checkable. Next example. I want something squared equals a number. Remember, that's my goal if I want to use the square root property. I don't quite have that here because this is 3 times x minus 2 squared equals 18. This 3 is in my way. So I'm going to divide by 3 first. And that's going to leave me with x minus 2 squared equals 6. But now I do have something squared equals a number. So I can take the square root of both sides, which leaves me x minus 2 equals the positive or negative square root of 6. Remember, you have to include that plus minus option. The square root of 6 is not a pretty decimal. This is not a perfect square, okay? It's not going to come out nice. So we're not going to convert this. We're going to leave it in exact form as we solve the rest. Now, you can do this one of two ways. I don't have to split it up if I don't want to. I could just add 2 right now to both sides and get x equals 2 plus or minus the square root of 6. And I can work with the plus minus within the problem if that's how you choose to do it. Or I could split out 2 different equations and say x minus 2 equals the positive square root of 6, or x minus 2 equals the negative square root of 6. And then perform the algebra, add 2 to both sides. The reason why I choose to add the 2 to the front instead of the back is because many students will tend to extend the square root sign over everything that's here. And that's actually not the correct answer because the square root of 6 happened first. The 2 is not underneath the radical. It's not underneath the square root sign. So adding it to the front avoids that common mistake. Having said that, there is nothing wrong with writing the square root of 6 plus 2, or the negative square root of 6 plus 2. But again, don't get caught in the common mistake of putting it all underneath the square root sign. Okay, they do have to be separate because they were separate steps that we took. So these are going to be 2 approximate answers if we get them in our calculator. So we can get the approximate answers. Every time we approximate, we use the squiggly equals. And we're going to get 2 plus the square root of 6, which gives me 4.4495 if I go out to 4 decimal places. Or I have 2 minus the square root of 6, which gives me approximately negative 0.4495. These, remember, are your exact answers, and these are your approximate answers. So also pay attention to how they want you to give the answer. Our last example for this video, find the x-intercepts of the function f of x equals 2 times 2x minus 3 squared minus 1. We need to identify any clues of what they're asking me to solve. And the clue here is the fact that they're saying x-intercepts. We know that x-intercepts are when y equals 0. So what they're asking me to solve is 0 equals 2 times 2x minus 3 squared minus 1. So that's the first thing that the x-intercept word is telling me to do. Okay, so just seeing that in the problem tells me that I have to set y equal to 0. But you also might want to make a note here that in the end, you need to have ordered pairs for your final answer. Because since they're asking for x-intercepts, we're not just going to stop at x equals or x is approximately those values. We want to write those answers as ordered pairs. So just you can add this here as a little reminder before you leave the problem. So now I know what I'm solving. I don't quite have something squared equals a number, but I can get there if I do a little bit of algebra. So add 1 to both sides first, and that gives me 1 equals 2 times 2x minus 3 squared. Then I would have to divide by 2 so that I get 1/2 equals 2x minus 3 squared. And now I actually do have the correct form in order for me to use the square root property. Something squared equals a number. So now I can take the square root of both sides. Remember, as soon as you do that, it's a plus minus that has to go in front of the square root sign. So it's going to be the positive or negative square root of 1/2 equals 2x minus 3. Now remember, you can solve this all in one if you want. You can add 3 right now as long as you maintain the plus minus, and then you can divide by 2. I'm not going to do that here because I want to make sure that you remember that you're getting 2 solutions. So we are going to write this as 2 separate equations to solve. So one equation with the positive square root and one equation with the negative square root. And now we're going to solve the rest of the algebra. Add 3 to both sides. So we get 3 plus the square root of 1/2 equals 2x. And then divide both sides, everything, by 2. And I get 3 plus the square root of 1/2 all over 2 equals x. So that was for my positive. Now let's work with the negative. I would do the same work, add 3 to both sides. So this is 3 minus the square root of 1/2 equals 2x. Divide everything by 2, and I get 3 minus the square root of 1/2 all over 2 equals x. Now remember, we were looking for x-intercepts, ordered pairs. So these are not my final answer. My final answer is going to be this mess, comma 0, and this mess, comma 0. Would you know what these values were just by looking at them? Absolutely not. So this is where I have to go to my calculator and actually find the approximate answers to be able to identify this on a graph, because I'm never going to be able to identify this as an exact answer on the graph. Okay, so I'm going to need a decimal here. You have to be careful with how you type these into your calculator. The whole numerator has to get done separately from the denominator. So if you want to do it all at one time, you would open parentheses and put 3 plus the square root of 1 divided by 2, all in parentheses, and then divide by 2. This is how it's going to have to look in your calculator. And depending on your model calculator, you might even have a separate parentheses under here. Okay, but you have to make sure that every group is marked off. So this is what you want your calculator to do. If you do that, you wind up with approximately 1.8536, comma 0, and approximately 1.1464, comma 0. And just like with the other ones, if you want to check, you can take these x values, plug them into the original, and see if you get 0. You won't get exactly 0 because remember, you rounded these, but you should get something very, very close to 0. And that will verify that you have the right x values. So pay attention to what the problem is asking. I know I said that at the last video, but I want to make sure I say that here again. Always pay attention to what the question is asking. This way you know if you'd answered it completely before you leave the problem. And also keep in mind that the square root property is only useful in very limited situations. So you may not be able to use it very often. So you have the other two techniques, the factoring technique with the zero product property, and the next video coming, which is the quadratic formula. So keep a lookout for that video and have a great day.